Puddles on Mars? This week on Planetary Radio. Hi everyone, welcome to Public Radio's travel show that takes you to the final frontier. I'm Matt Kaplan of the Planetary Society. Principal investigator Peter Smith told us months ago that the best of the Phoenix Mars Polar Lander mission might be yet to come. We got proof last week when a team led by Nilton Renno announced that what looked like drops of liquid water on one of the Phoenix landing struts were exactly that. Dr. Renno will tell us much more on today's show, including how those droplets managed to stick around, possibly for days. Bill Nye, the science and planetary guy, will tell us what a new electric car and space exploration have in common, and Bruce Betts will help us find a planet or three in the night sky. Emily Lakdawalla has the week off, so we've got a Q&A classic for you. Discovery is back on Earth. The shuttle successfully delivered to the International Space Station everything from new solar wings to a replacement urine processing unit. Listeners tell us the combined ISS and shuttle were a spectacular wandering star. There's an amazing story at Planetary.org by my colleague Amir Alexander. It tells the tale of the first asteroid to be found and tracked before it impacted Earth. Fragments were later found in the Sudanese desert. Here's Bill.
Hey, Bill Nye, the planetary guy here, Vice President of the Planetary Society. And last night I did an awards presentation for scholarships for middle and high school kids who are excited about science and excited about the future at the California Science Center. Earlier this week, I was at the unveiling of the Tesla Motors Model S, and S means sedan. This is an all-electric car that will outperform almost any sedan you can think of in acceleration, in comfort, in room inside, and of course in carbon footprint. And that car is being designed by Elon Musk, who is on the board of the Planetary Society and who serves to inspire young people in middle and high school to pursue careers in science. Now, what does this have to do with space? Well, the same guy, inspiring the same kids, is building the SpaceX Falcon rocket and the SpaceX Dragon capsule to take maybe some of these kids into space. This guy is building this stuff in the U.S., inspiring U.S. students to pursue careers in space exploration and car design, to be engineers and scientists of the future, so that we can address climate change, carbon footprints, and explore where our world is with regard to all the other worlds. And all this stuff happened to me in the course of a couple days. Very exciting time, my friends. The Planetary Society attracts heavy hitters, and so all of you that are tuned in, I'm going to call you all heavy hitters as well. We have the ability, through gently influencing people in governments around the world and in our own work and our own jobs, gently influencing people to pursue math and science and explore space. Ever so slightly, all of us, I hope, are going to change the world. Well, thanks for listening. I gotta fly. Bill Nye, the planetary guy.
The first thing you need to do is follow the link at planetary.org/radio to see what Nilton Renno says are drops of liquid water on Mars. Renno is a professor of atmospheric, oceanic, and space sciences at the University of Michigan. His presentation at last week's Lunar and Planetary Science Conference represented work by scores of colleagues, including Phoenix mission principal investigator Peter Smith. It explained how the salts, or more precisely perchlorates, in the Martian soil around Phoenix could lower the freezing point of water enough to keep it liquid, even in the terribly cold conditions near the Red Planet's North Pole. I talked to Nilton not long after he had returned to the Ann Arbor campus. Dr. Renno, I want to thank you very much for joining us on Planetary Radio. And let me start with this statement. Everybody knows that there is no persistent liquid water on Mars, right?
Mm-hmm. Right. Except for really saline water. And that's what we were talking about, highly saline water.
Your research, was it inspired by these images of these little droplets of something on the legs of the Phoenix lander?
Two things. First is that one of my graduate students here at the University of Michigan, his name is Manish Mehta, he did an experiment to look at the effect of the Phoenix landing thrust at the surface of Mars. And what he discovered was that Phoenix was going to completely remove the topsoil and expose the subsurface ice during the landing. And so that first image that we had of the ice was basically we were pushing for this to search for, to test his experiment and theory. Then what caught my attention was the things in the strut. From the thermodynamics, my background's really in atmospheric thermodynamics, I knew that liquid water was very unlikely, but because it's too cold in the landing site region, but it would be possible if it could get warmer. But a saline water would be really, really easy to make there if there was enough salt on the ground.
Before we get to those salts, I first of all, this is the first I'd heard that it was one of your students who realized what the effect of those thrusters would be as Phoenix set down on Mars. And of course, at first, there was a lot of worry about how those would really hurt your ability to do science at this site. Yeah. And as Peter Smith has told us on the show, it turned out to be a blessing in disguise.
Exactly. Well, we were, how to say, optimistic about the success of the landing, and we were really excited when we found out how much soil was going to be removed, because it's a science experiment. We can calculate some of the properties of the soil based on how much soil was removed. That's why we were very interested in the images under the lander.
That's yet another point that I have not heard before, that you were actually able to tell more about the composition of the soil because of these rockets.
Yeah, we can tell about the porosity of the soil. And what Manish discovered is that the fact the plume is pulsating at 10 hertz. When the plume penetrates to the soil, and then between pulls, the soil starts expanding. When the soil starts expanding, it gets fluidized, and it behaves as an atmosphere with molecules that are very heavy. So that means that the speed of sound goes down by orders of magnitude, more than 2 orders of magnitude in the soil. Then when the next blast comes in, that creates shock waves, supersonic shock waves through the soil. And we have been calling this explosive erosion. And the explosive erosion is constrained by the porosity and cohesion of the soil. So if you know how much soil was removed, we can calculate those two parameters. And that's what we did. And we have a paper that we are planning to submit to science almost ready to go.
You can't see it, but I have a big smile on my face because this is such a wonderful story. It's just fascinating to see how much science could come out of something that looked like it was only going to be destructive. What is the name of your student once again?
Manish Mehta.
Well, we will congratulate him, and we'll watch for that name in the future of planetary science.
Thank you very much. He's a very creative, very smart guy. And, then the other thing that he discovered was that he did some calculation. We published a paper last year on JGR, was that just the compression of the plume over the ice would probably melt a very thin layer of the top of the ice. That's why when I saw those things on the strut, I immediately thought, well, that was probably a mixture of the soil and this mud created by the melting of a little bit of ice that splashed under the lander. And then we kept watching it, taking images as frequent as we could. The next thing that caught my attention was that those things were first moving around, and that there is different growth between particles of different size. And that's consistent with saline solution getting more or less diluted depending on how much water it's absorbed from the atmosphere.
And we will have to put up a link to the University of Michigan page where I found these images of these droplets. It looks exactly like, watching droplets of water condense on the side of a cold glass.
Exactly. Yes, exactly.
Watching them merge and how long does it look like these actually persisted as a liquid on the leg of Phoenix?
I think at least for about 5 days, because initially the mean temperature was going